This point, we've been solving equations, and equations always have an equal sign in them. This video is going to start us working with inequalities, which simply means not equal. So we are most likely going to be looking at problems that will end with something like this that you've probably seen before. This top inequality is written and said as x is any number that is greater than or equal to -3. When I create a number line, I almost always put this number as close to the middle as possible. I then fill out what's left in each direction, and then I'm going to shade my line. Now, if I have a greater than or equal to, or I have a less than or equal to, that means I want a closed circle, because in order to make this statement true, the number -3 is one of the possible solutions. I am then going to shade any number that is bigger than the number -3. I always remind myself that I'm shading bigger because I think of this as an alligator's mouth, and I like to sometimes draw little teeth and then a crazy little eyeball. And alligators are very hungry, so they're always going to try to eat the bigger number. In this case, it's x. The one on the bottom, I have a is any number that is smaller than 6, because once again, the alligator is going to be eating the 6. So my a has to be smaller than that. So I put my 6 here. I fill out the rest of my number line. And if I have a simple greater than or I have a simple less than, we are looking at an open circle, because the number 6 does not make this statement true. So 6 is not one of the solutions. I also want to be very, very careful, because there are some tricks out there about following this point to see which way it's shaded, but that only works if the variable is on the left side. If you need any practice on this shading, make sure you talk to me. Now, in order to solve an inequality, we are going to solve them exactly like we are working with an equal sign or an equation. So I'm going to treat this exactly like what I've been doing before. My line down my equal sign, and I'm going to solve. I see parentheses, so my first step is always the distributive property. 4 times 2y is 8y. 4 times 3 is 12. Everything here is positive. And now instead of an equal sign, I'm sticking with greater than or equal to. I'm now going to subtract 12 from both sides of my equation. And I get 8y is greater than or equal to 8. My last step is I divide everything by 8, and I get y is greater than or equal to 1. From here, I just simply shade like what I've been doing, except that I did a little bit more work before I got to this point. So my number 1 is right here in the middle. 1 is one of the solutions, so I can shade it. And the alligator is eating the variable. Therefore, I want all numbers that are bigger than the number 1. In order to check my answer, I have to take one true number and one false number and plug it back into the original equation. Anything shaded should make a true statement when I plug it back into the top. Anything in the unshaded portion should make a false statement when I plug it back into the top. So I can pick any number in my solution. I'm actually going to pick the number 5, because it's in the shaded portion over here. And now if I have the choice, I always like to pick the number 0. So for the false portion, I'm going to pick y equals 0. I'm going to plug each of these into the original equation. This part should make a true statement. This part should make a false statement. So for the y equals 5, I'm going to plug in 4 parentheses 2 times 5 plus 3 is greater than or equal to 20. 2 times 5 is 10. 10 plus 3 is 13. This is 52, which is greater than the number 20. which is what we wanted. We got a true statement here. Now we want a false statement from the y equals 0. I'm going to plug it in again. And this time we do not want it to be greater or equal to the number 20. 2 times 0 is 0, plus 3 is 3. And 12 is not greater than 20, therefore we have a false statement. So for 5 SPs or 1 piece of candy, you can come to me and tell me that in order to check your answer, you need 1 false and 1 true statement. For our next example, we're going to get a little bit more difficult, but not terribly. There is 1 new step that we're working with in this problem, and this is also going to be worth 1 piece of candy or 5 SPs, depending on what I have. That if you ever multiply or divide by a negative number, so not add or subtract, only multiply or divide by a negative number, there is 1 new step in these problems. You must flip the sign. Very easy to forget this. So 1 piece of candy or 5 SPs, you come up and tell me that you must flip the sign when you multiply or divide by a negative number, and you'll get 1 piece of candy. For this problem, we're going to solve it just like we've been doing before. We have no parentheses here, so we are just going to subtract 6. I always do that from both sides. I get negative 3x is less than positive 3. From here, I'm going to divide by a negative 3. And I just realized that we just talked about this. I divided by a negative, which means I'm going to flip the inequality sign in the middle. So I'm going to get x is greater than negative 1. Now, once again, I'm going to put my negative 1 as close to the middle as I can. I'm going to shade this time to the right, and it is going to be an open circle. Now, to check my answer, I need 1 true and 1 false statement. So I'm going to take from this side, I'm going to do x equals 0. I love working with zeros, and we're hoping that this creates a true statement. And on the opposite side, I'm going to take negative 3, but it could be anything. And I'm hoping this creates a false statement. Now, for the negative 3, I'm going to do negative 3 times x, which is negative 3, because that's what we picked down here, plus 6 is less than 9. Negative 3 times negative 3 is positive 9, plus 6 is less than 9. This is 15. Therefore, this is a false statement. And on the right side, if I plug in 0, negative 3 times 0 plus 6 is less than 9. This is equal to 0. 0 plus 6 is 6, which is less than 9, which does make this true, which means we must be correct. Now, if I didn't flip the sign, that means my shading would be in the opposite direction, and therefore my false and true statements would be reversed, telling me that I had made a mistake. So very, very easy to make small mistakes on these problems. So as a small hint, I left these reminders. Make sure you have these written down in your notes so that you don't make some of the small mistakes with inequalities. As always, if you have any questions, please let me know.